All right, Mr. Spooner here to teach you about absolute value and then do a little fraction multiplication and division review. All right, so first of all, absolute value, the definition is the distance of a number from zero. And you'll see how that actually helps you when you're doing some problems. But absolute value is the distance from zero. So if you think of the absolute value of 6 in these little lines here, that is what absolute, that's how you tell the world that you're trying to do absolute value. If you think of 6 on a number line, how far is 6 from 0? Well, the absolute value of 6 is 6. Now, distance always has to be positive. So if you think of how far is negative 6 from 0, well, that's also 6. So you see that two things. Number one, absolute value is always positive. Number two, or I guess it could be 0. Number two is the absolute value here of 6 and negative 6 gives you the same answer. So why don't you pause the video here and see if you can figure out what the absolute value of these things would be. All right, and we're back. This one's going to be positive 30, positive 21, positive 2. And then look at that. The absolute value of positive 1/2 is just 1/2. So I know when I was a kid, I didn't actually think about the whole distance from 0 thing. I just thought those little absolute value lines make the number positive. And if it is already positive, you keep it positive. All right, so how would you do a problem like this? Well, absolute value, if you're thinking about order of operations or PEMDAS, what do absolute values look like? They look like parentheses, and that's how you're going to treat them. So in this case, you don't have much to choose from, but you're going to do whatever's inside of the absolute value first. So I'm going to actually do negative 5 plus 2, which is negative 3. So this turns into absolute value of negative 3. And the answer, when you do your absolute value, is just positive 3. So let's do one more together. We do what's inside the absolute values first. You're treating those like parentheses, so that comes first. Absolute value of negative 5 plus 2, that's negative 3, and we're adding that. Absolute value of negative 6 minus 3, that's going to be negative 9. Now we're actually going to deal with our absolute values. The distance of negative 3 from 0 is just 3. Absolute value of negative 9 is 9. Add those up, and you get your answer of 12. Not too bad. All right, why don't you pause the video right now and try this one? All right, and we're back. Did you get negative 11? If so, nice job. All right, what do we do if the absolute value is on the outside? Well, first, we got to deal with our P for PEMDAS for order of operations. So we're going to do what's inside the absolute value first. So we'll leave that negative 2 alone. Negative 3 minus 1 is negative 4. Let's actually do the absolute value of negative 4. That's 4. And then, remember I said absolute value you're treating like parentheses. So if you had a number outside of parentheses, you would multiply. That's what I'm going to do here. So I'm going to do negative 2 times 4. And my answer is going to be negative 8. All right, how about these here? What's the difference between all of these? Well, again, we're going to do our absolute value because that's like parentheses first. Then we're going to do our exponents. So this one, you would do absolute value of negative 3 is 3. So I'm sorry, I already did the absolute value there. Those are gone. And we get that 3 squared is 9. How about this one? Absolute value of 3 is 3. 3 squared is, hey, wait a second. That one's 9 too. What about this one? Negative 3 squared is going to be negative 9. Inside the absolute value, take the absolute value. It turns out that all three of these end up being the same. So remember, when we did something like this with parentheses, some were negative, some were positive. Unless that negative sign is on the outside of the absolute value, they're all going to turn out positive this way. All right, I've got a couple for you to try here. Why don't you pause the video? All right, come back. Did you get negative 12? If so, that's great. If not, take a look at what I did. How about another one? Pause the video, and we're back. Did you get negative 1? If so, awesome. And I believe that's it for absolute value. So hopefully that helps you out with your homework. If not, talk to your teacher. Let's do a little fraction and multiplication division review. So with fraction multiplication, you are just going to multiply across with the numerators. 2 times 5 is 10. 3 times 7 is 21. I always do a little check. Can I reduce that? Does anything go into 10 and 21? Nope. we're done. How about when something can reduce? Well, I do something that sometimes I call it cross canceling. It's reducing. The idea is that any um, thing in the top can be reduced with anything in the bottom. So take a look at this 3 right here. I know that the 3 and the 9 can be reduced. 3 goes into 3 once. 3 goes into 9 3 times. So I reduce that 3 over 9 to 1/3. Same thing with the 8 and the 4. I can reduce this to a 2 and this to a 1. And now I can multiply across. 1 times 2 is 2. 1 times 3 is 3. And you get that as your answer. Just to show you what would have happened if you hadn't done that reducing at the beginning, you'll actually still get the same answer. You'll get 24 over 36, which will then reduce to 2/3. I find when I'm doing these, it's a lot easier. You deal with smaller numbers if you do that cross canceling, that diagonal reducing in the beginning. So what happens if we do fraction division? This is the only time I think in math where I actually like my little tricks, but I do keep, change, flip. You might have heard keep, change, rearrange. I'm going to keep the 7 over 2. I'm going to change the division sign to a multiplication sign, and I'm going to flip my 3/4 to 4/3. Um, the reason this works is by dividing by a fraction is the same as multiplying by a reciprocal. But I'm telling you, even at age 39, I still think about keep, change, flip. It's pretty much the only little trick like that I use. Anyway, from here, what can we do? We can do a little cross canceling, reducing here. That's 1, that's 2, and we end up with 14 over 3. Can it be reduced? No. Do you want to put it into a mixed number? Nah. So we're just going to leave it as a top-heavy fraction, 14 over 3. All right, one more. What if you've got a long multiplication problem? Well, here you definitely want to do some reducing before you get going. Any top with any bottom. So just to show you, I'm going to reduce the 3 and the 21 here. 3 goes into 3 once. 3 goes into 21 7 times. Ooh, look, I got the 7s here. 7 goes into 7 once. 7 goes into 7 once. How about the 9? 9 can become a 1. 36 can become a 4. Multiply across. And look how easy that is. Nice small numbers. Your answer is 5/4. And that is it for me. Absolute value, fraction, multiplication, division. See you later.